Thank you. Welcome, everyone. So I'm very excited to give this talk to you about how to build and run an AI-powered product. And I will demonstrate it with an own product in progress. It's called Storique. But let me introduce myself first. So I'm Valentina, an applied mathematician. I've been working in the past 6 years in Switzerland as data scientist and also in the and also in the AI planning research and in the industry. And I'm the co-organizer of the Swiss chapter of the Women in Machine Learning and Data Science Association in Zurich. I'm passionate about tech conferences, sharing knowledge and experience, traveling, diving, and especially brainstorming and hacking on projects with my husband, Max. And I'm going to present such project now as well and share my experience of building an AI product with you. Why do we focus on this today? Because it has never been more accessible and easier than today to build projects with AI. Thanks to cloud providers like OpenAI and open source communities like Hugging Face, there are a variety of models which make it possible to build stuff without the need of having a team of computer scientists, professionals, or an expensive computer cluster. Everything is accessible to create a product from it within a short time. So even if it's easy, the part of the development is racing with time, with competition. And new major breakthroughs come out weekly, and it can be difficult to stay up to date. These are just some of the pitfalls you can face when developing an AI product. While many models are free or very affordable to use, experiments and fine-tuning come with high computational costs. So it's not easy to find the perfect model for your project. It's crucial to do your research and find the best stack for your product. And I'm going to show you how I navigated those pitfalls. And I'm going to demonstrate it with one example. So Storique. What is exactly Storique? It's an application which allows the creation of unique storybooks with AI-generated illustrations and AI-generated dynamic text and stories. So on this picture, you can see my nephew. He was the first person who ever received the book created with Storique, and we created for him a story which is about him and his cat exploring the forest and getting to know the animals in the forest. And we achieved this with our own software, Storique. And we saw that it's incredibly fun working on Storique and also using it. So we wanted to make it accessible for anyone. The first version we made was only for our own use, and the pictures in it were not at all consistent in it. So it took months for us to experiment with models to achieve what we imagined. And as we worked on Storique, we realized how much joy the results bring. And we wanted to achieve a version which anyone can easily use. The key is personalization, and which technology enables us to create such personalized pictures. It's the diffusion models. It's a family of supervised learning algorithms. It's a type of generative AI model which can be used to create completely new images. And all diffusion models use noise to encode an image, and they use a noise predictor with a reverse diffusion process to put the image back together. They consist of three main components, and each of them are different neural networks. In Storique, we use Stable Diffusion XL. It's developed by Stability AI. And the reason why I chose this model for our product or project is follows now. So we have to take a look into the stable diffusion architecture. The rows of the components are the following. The first component is the variational autoencoder. This encoder maps the input image into a latent space. And the decoder has the opposite function. It maps from the latent space into the input space. So the outcome is that we are working with a smaller image in a latent space. This causes us effectiveness. The smaller latent space is based, the effectiveness of this smaller latent space is based on the idea that natural images follow patterns rather than randomness. And stable diffusion can capture intricate details such as eyes due to this variational autoencoder. So the next two steps, the forward and reverse diffusion, are the process when the algorithm actually learns to create images. So the forward diffusion process adds Gaussian noise to image progressively until only randomness remains. And this is used only during training. But the reverse diffusion undoes the forward diffusion. And this is what we are actually using. It's been trained on billions of images using prompts to create new and unique images. So during the forward and reverse diffusion process, we are actually training a noise predictor, which is the UNet model in Stable Diffusion 1.5 and Stable Diffusion XL. But in the newest stable diffusion model, is Stable Diffusion 3, they are using rectified flow transformer. This model is not yet available to fine-tune. It's, according to the research paper, it's very promising, so I'm really looking forward to apply this on our product. And the fifth component of the stable diffusion architecture is the text conditioning part. We are using this CLIP, contrastive language image pre-training model. It's also developed by OpenAI. It's a multimodal vision and language model. And what we achieve with CLIP is that it maps images and text descriptions to the same latent space. And it allows to determine whether image and description match. And we achieve this by jointly training the encoder and the text decoder. We do this with maximizing the cosine similarity between the image and the text embeddings of real pairs, while also minimizing the cosine similarity between the embeddings of incorrect pairings. So, thanks to this great architecture, Stable Diffusion stands out by not using the pixel space of the image, instead using a smaller latent space. It is very precise due to the UNet architecture, and it's even more precise in Stable Diffusion 3 due to the rectified flow transformer. And with this, we can achieve high quality images as a result when using Stable Diffusion. It's been trained on Lion Aesthetics dataset. It has a very high aesthetic level, so it can create very realistic pictures, and it can be personalized and customized. While the other good generative models for generating pictures like DALL-E and Midjourney, with those it's not possible to create such personalized results. So we obviously do not implement it ourselves. It's a very complex model, and it comes with high computational cost. If we want to train such model, we can find on the internet, for example, the civitAI.com, different versions of Stable Diffusion models. Like the middle one, you can create anything out of X with prompts, or out of bread. It's very exciting to experiment with such models. Stable diffusion is working so well, and it caused a breakthrough in image generation due to personalization, and that you can create such models with it. We also fine-tuned our own model, and I'm going to tell you about how. So we wanted to fine-tune the model so that it can learn task-specific features while keeping the general features learned from the pre-trained network. Our goal was to achieve a model which is able to create pictures in a watercolor painting style. And there are different ways to fine-tune a stable diffusion model or any large language model, because stable diffusion was originally a large language model, and it was just later discovered that it's perfect for generating pictures. The first option is textual inversion. It's not really the case we will go for, because you can only edit the prompts with textual inversion, and we actually want to teach those pictures, like from my nephew, to the model. So it's not our go-to option. The second one is Dreamboot. It's a very, very efficient model developed by Google Research and Boston University. For fine-tuning, you only need 3 to 5 pictures, but it comes with a very intense calculation, because it does actually fine-tuning twice, and it does edit the entire model, because first you are fine-tuning a low-resolution text-image model with a set of reference images with titles, and later you fine-tune the model again, actually the super resolution component, which allows you to create very high resolution pictures. But for our case, it's not necessary, because we wanted to have pictures like in a children's books, not too realistic pictures. So we found LoRa. It's a low-rank adaptation developed by Microsoft Research. It's a mathematical technique to reduce the number of parameters that are trained, and it freezes the weights of the original stable diffusion model and adds new layers into it with rank decomposition weight matrices for training. And it creates a difference to the maze model, and the training with LoRa is much faster. It results in a model file which is much smaller than with Dreamboot. It uses much less VRAM than Dreamboot, since the new layers have significantly fewer parameters than the original model. And while Dreamboot excels at generating highly accurate and detailed images, with LoRa you can create artistic pictures and imaginative results. So first, we fine-tuned the base stable diffusion model to our own style. We needed first training data, and we used Midjourney for generating thousands of pictures according to our prompts in a desired style. Here I have a few examples, like this picture of the deer. Is exactly in that watercolor painting style we wanted to see in our children's books or storybooks, and we needed a very detailed caption, a deer standing in a forest next to a stream. It's possible to create these captures with GPT-4V, but we did this manually because we wanted to achieve the best result possible, and we wanted to create our own titles for good training. And we needed high diversity of characters as well. We generated thousands of images mid-journey, but we only kept like 10% of them, only the best quality pictures. And we picked those pictures manually because this training was very important for our model, because later we used this model and fine-tuned again. So this model had to work very well and had to create the pictures in exactly this style we wanted to achieve. So that was our goal, and our goal was also to be able to create pictures of persons where the persons are recognizable but not too realistic. So the next step was fine-tuning stable diffusion for persons. This was the most challenging part of the development and took much of our efforts, because we used again the LoRa, but since this fine-tuning happens by the actual user of the app, it has to be very optimized. There is no universal tactic for optimizing a model. It's always a unique solution for your needs, for your case. And it's a trading off between generation speed and image quality. But 2 points might work for other projects as well, because for Storique they work very well. The first is that by default models run at a floating point 32 precision on GPUs, meaning that the calculations with 32 significant figures of precision happen. But we realized that it works also very well if we run it at half that precision. So floating point 16 needed less time and VRAM, and we could still achieve the quality of results we needed. And the second one, we realized that stable diffusion does the inference with 50 steps. So when we give stable diffusion a prompt, it starts with a noisy image, and it creates the desired picture within 50 steps. And we realized that for our case, that we don't want too realistic pictures, it was enough to only have 20 steps. And with limiting steps, we could reduce the inference time, so the user could run and create stable diffusion generated images much quicker. So it does not only depend on the model or the developer how high quality images come out from the model, but also the user has the responsibility to upload only eight, but very high quality images. So we also pre-process the pictures. We cut them. Only the upper body of the trained person is visible on the training pictures. And we also transform the pictures into the desired resolution with which stable diffusion works the best. But the best result can be achieved only if the user does not upload pictures where the trained person is wearing sunglasses or hats, because that would influence our model a lot due to the low sample size. When a user wants to train a person to our stable diffusion model, or actually it's a fine-tuning, not a training, it has to define a unique token. For example, for my nephew, his name, Laurie, is the unique token. And when we want to generate pictures of Laurie, we want to add to the prompt and this unique token. Otherwise, we will merge it with the existing knowledge of the Stable Diffusion model. Even if it's a very robust model, the Stable Diffusion shortcomings can be seen in the results. If the person is wearing the same clothes on all training images, then it's unable to generate any picture, or it's very difficult to prompt in a way that the person is wearing anything else than those clothes. And it's only hard to achieve like the actual human body look, because it can often produce 6 fingers on the hands. So that we cannot avoid yet, but as I told you, Stable Diffusion 3 seems to be very promising. The API is not available yet. As soon as it's going to be available, we will surely give it a try and test it. So now we have fine-tuned models. The user is able to fine-tune the models thanks to Aurora. And now we can use this model, and we can use the diffuser's Python library to call the model, to give it a prompt, and actually generate pictures. The diffuser's library is Hugging Face software, and Hugging Face is an open source community. It's an ecosystem like GitHub for machine learning models, and it's very easy to use the diffuser's library. We can upload our own model to replicate, which I'm going to talk about later. And with the diffuser's library, we can call our own fine-tuned model and generate pictures with this short code. So the next step is deployment. It's the moment when you can actually give the model available for use. So first, in the experimenting phase, we were using Google Colab for experiments, but in production, we are using Replicate. And Replicate is a great software because we can freely choose the hardware we want to run our model on. We pay only for what we use of computing power. It has an API, so it makes it possible to use it in our web application. It supports queuing, so you can actually scale access the model when multiple users try to use the app in the same time. And Replicate also has ready-to-use models like Stable Diffusion, but it also offers the possibility for deploying your own models. While using Replicate, we realized that it's efficient for inference, so efficient when we want to use it for generating pictures. But for training, we want to explore new solutions because it's kind of expensive for training. As I told you, with Storique, you don't only generate pictures in your storybook, but also text. And for text generation, we are using LangChain. So putting large language models to real-world solutions requires engineering work, and we wanted to save that work. So luckily, we found LangChain. It's a framework to construct large language model-powered apps with a few lines of code. And it's representing common steps and concepts necessary to work with large language models. These modular components from LangChain serve as building blocks of generative AI programs. It's possible to train multiple models. So, for example, you can extract data from tables with one language model, then analyze trends in the data with a second language model, and also you can have a third model for generating insights briefing. It's a good tool. We didn't use chaining in Storique. We used LangChain for prompt processing with the GPT 3.5 model, and we generated the text in Storique, or the user generates the text in Storique with the Claude 3 Opus model. So there are many other features like benchmarking different models in LangChain, so I highly recommend you to use it because it's important to not only rely on one single model, but to have the possibility to switch between models, to experiment, and not having to have to rewrite the entire code. So we also need a web application to make our product accessible for the users, and we developed it with the Nuxt.js framework, and it was written in TypeScript. We used Supabase as a backend service, and also as a database. As database, we use Supabase for authentication and also for object storage. We also want to get paid for our products, so the easiest way to integrate payments is with Stripe. According to our research, this stack makes it the most simple to build such an application like Storique. And here I created a short demo that you can see how actually the application looks like, what's the result. So this is our web application. It's very simple so far. We have this product available in private beta only and only in Switzerland. So we are experimenting with it. We want to see what the users think. So this is a simple version, but I hope that we can go further and we can develop a beautiful application soon. So yes, we want to create a new book, and we want to add people to train the model. Yeah, so we click on Add People. And here we can add the name of the person we want to include in a book. It's Valentina, 28 years old, and we can choose the 8 pictures for training. And then we also want to create another person. We can create up to 3 persons in a book at the current version. So it's going to be Max, 30 years old. And we also upload some pictures. We can also add additional information for the training. So, as I said, we only need 8 pictures. We only kept the best quality ones. And now we can start training for both persons. And it takes approximately 30 minutes to train. So after training is done, or actually it was a LoRa fine-tuning in the background, not a training, but the user doesn't notice anything of that. we have the book wizard. We can choose the actual characters we want to write a book from. And previously we trained the third character. We only want to include in this book Max and Valentina. And you can pick if you want to write your book manual or AI assisted. Obviously, AI assisted is more fun, it's quicker, and you can actually click together a book 24 to 36 pages within 30 minutes with the AI assistant. And which language the story should be written in? We pick English. So first we need a main idea for the book, and the book wizard gives you 3 options. Well, none of them seems to be appealing for me, so at least in this demo, so I give some input to the model. The story should be set in San Francisco. Regenerate ideas. And the middle one, Max, a talented baker, and Valentina, an aspiring artist, team up to create the most extraordinary and colorful bakery in San Francisco, inspiring children and adults alike to follow their dreams, no matter how unconventional. We will pick this story. It's a bit dummy, but it's just a demo. So then there is an option to give book title and author. We rewrite this title because we don't like it. Max and Valentina in San Francisco. And then this UI comes. This is the actual book. And you can fill every page either with pictures or with text. So it's the first time we are prompting generating image. So as I said with add, you can include a pre-trained person. Valentina standing in front of the Golden Gate Bridge. That's okay. That should look like me. Let's add also Max. They are both standing in front of the Golden Gate Bridge. Sometimes the second person disappears. That's a shortcoming of Stable Diffusion, but we can regenerate the picture as long as we pick one which we like. So let's write a text, and the AI wizard gives you page for page the story. So, in the heart of San Francisco, where the streets are lined with dream and whispers of magic, lived Max, a baker, whose hands could turn flour into tails. Okay, that sounds like a fun story. Then it goes later that one sunny morning, while the city stretched and yawned, Max and Valentina met by chance under the shadow of the Golden Gate Bridge with a basket full of freshly baked goodies. So I want to have such a picture of Max with a basket of freshly baked goodies. Let's illustrate it. I click on Add Page on the picture icon, and I prompt it. Max holding a freshly baked bread. There you go. The bread looks a bit like an artichoke, but this picture looks better. I'm going to pick it and include it in the book. So it goes on and on, page for page. You generate either a story or a picture illustration. In the newest version of Storique, we also include a suggestion for prompt for the illustration for a picture. So we want to, we develop it day by day to make it easier for the users. We are monitoring our beta users, how they behave, how they interact with the application, and we always add some extra feature to make it more accessible, easier, simple for them to generate a book within a short time. Okay. Before the takeaways, I'm going to show you something. Can you give me? So, Storique is not only a software, but we only have like a supply chain around it. So, you can actually get a book posted, yeah, with colorful illustrations. It can become a great present. You can also not only illustrate those persons, but anything you want to include in the book. So the moment when we first gifted someone with such a book, Laurie, my nephew, it was a very special moment, and I really hope that others can also use Storique to make their friends, their family happy with such a personalized book. Yeah, but today the focus one was on the technology around it. So the takeaways of this presentation, that it's easier than ever to build an AI product, an AI project, and you should experiment, because it's fun, and there are so many excellent software which make this project easier, that it's a very great age to live in. And the second takeaway is follow the development of new models, because week for week new models come out which might save you a lot of time of fine-tuning, of refining your model, so you never know what research is going on, what could make your product development easier. I can highly recommend using services like Replicate for deploying your application, and also I can highly recommend using LangChain when building large language models, because you can use the abstractions of LangChain and you can make your development simpler. So thank you so much for your attention. I will be happy to connect you on LinkedIn, and I'm ready for questions. Yes.
How long does it take for train images or generate images
From Midjourney? Yeah.
I can answer that. Yeah, it took us some time. At first, we did a lot of manual drafting stuff until we figured out rough that more or less reproduce the style that we want. And then we automated it basically, and just gave it a huge list of prompts. And then we let it run.
Yes.
I have a few more questions regarding the answer.
Okay. It's not open source.
Yeah, Midjourney doesn't provide an API, so we just scripted something with Playwright and automated it. Okay.
And my second question is, how did you manage to make any information, how to manage the character content? So that, the people who uploaded the paintings, they look like you. Was it all the time in those things?
Yes, I mean it's a very efficient software for personalization, stable diffusion. We were experimenting a lot with the actual parameters of the model, so that took a month. That took months for us to pick the right parameters in order to have like recognizable results, not too realistic, and also we had to work on the quality of the picture so that it's consistent and that it's the best input for the stable diffusion model. But we experienced horrible results in the beginning. It was a hard path to get such results, and it's also thanks to researchers who are developing stable diffusion further, because the first version produced scary images. But with stable diffusion XL, we could achieve this result, that we are actually recognizable. It's not always the case, so we have to sometimes regenerate the picture. It can happen that every second picture is inequality we want to achieve, or in a way of recognizable quality we want to achieve. But it's all about the model parameters. Yes?
And then for the stories, are you using ChatGPT to generate that? How are you doing the story? Images is stable diffusion, and stories is something else.
Exactly. So we are using GPT 3.5 for pre-processing the prompts to make it easily readable for stable diffusion. But for generating the text of the book, we are constantly experimenting with different models. And thanks to LangChain, it's very easy to switch between models. And currently we have a model, Cloud 3, which we are using for generating the actual text. And we also have like a series of system prompts in order to make it sound like a book for the age for which it's written for. Because as you've seen, this book I read to you, it was very complicated. It used elevated words, expressions, and if we want to give a present to my 5-year-old nephew, we don't want to have such words in it. So we use system prompts in order to create a story which is readable for the person we want to give the book to. Yeah. Yeah. So the beta version is already available in Switzerland for those who edit their email address on the website. The limitation of countries due to the shipment, because we are producing these books in Switzerland, and it's a work in progress to find the partners to work with in different countries. In which country are you interested in? Oh, that's easy.
How long do you stay here at
Until Sunday. I'm in the States on the conference until Thursday. That would be great, yeah. Yes.
With that, I was curious.
Yes.
How do you guys previously follow your right? Like, you generate an image that's actually fall under that category? They're not personal, right?
Mm-hmm.
Yeah, that's a good question. So we are using a Superbase, and like Superbase is like our cloud
provider also, oh, thank you. And a storage provider, and so we rely on them basically for securing that. But Superbase is quite cool. It's also possible to write like HIPAA compliant software with Superbase. So yeah, in the end, we're gonna delete all the pictures anyway because, well, they use up a lot of space.
Yes. So the user has the possibility to immediately, after fine-tuning, delete the images, and only the weights of the neural net remain, with which we can create pictures of the person. So we don't keep the pictures in the end, just weights of neural nets.
My follow-up to that is, what if you guys potentially could have generated image multiple times, right? Like, but that actor wanted to do things, from,
You mean someone who paid for our product and then just uses it to generate? Well, there's a maximum amount. We limit the generation to, I think, like 1,000 pictures per project, which should usually be enough. Yeah. Per generation, I think it's like 4 cents or something. Yeah.
Yeah, but that's the tricky part, because the reason why we needed all those optimizations with reducing the number of steps, the switching to FP16, the reason is the cost, because language models are cheap, generating text is very affordable, but generating pictures and video is not yet that affordable. So we have to take every chance to optimize the model, because we want to have an affordable price, and also for us, we don't want to pay too much for our cloud providers.
those 8 images, the number, the fixed number, is that like, get diminishing returns after that, or does it like saturate the model in a way it's going to be identified?
Yeah, no, that was that was a choice, because we just realized that with 8 pictures we already get very good results. So there's not really a reason for the users to provide more than that. Also, if you limit the number of pictures they should provide, then there's a lot more focus on just providing like very high quality pictures. And also for us, it uses a bit less resources when it's less images, and it works well.
My last question is, what do you actually use for translation? I saw that you had a list of languages, but what does that actually use?
It's also one large language model. It's a GPT 3.5.
It's Claude 3 for the text generation, but yes, I mean those large models, they typically like are capable of understanding lots of different languages.
So you generate it in the target language, or you always generate it in one and then just do a translation step after?
No, we generate in the target language.
Over. Okay, sorry. Thanks for the great questions, and see you later.